Hey guys, today we're going to start chapter 4. So today we're going to graph systems of equations and two variables to find an approximate solution and an actual solution, and then we're going to use some word problems to do this as well. So this is 4-1, solving systems of equations by graphing. So first problem, we're just going to graph and see where we find the solution. Okay, so our first line is y equals negative 2x minus 4 and y equals 0.5x plus 6. We want to use a graph to solve the system of equations. So to do this, the first thing we do is graph both of the equations. And then we look for the point of intersection. Okay, so the two lines are going to cross. That means that that point is our solution because it works for both lines. Okay, so let's see, I'm going to do this line in red. Okay, so y equals negative 2x minus 4. We should be pros at graphing this by now. Okay, so my y-intercept is negative 4. Remember, this is the y-axis, so 1, 2, 3, 4. Okay, my slope is negative 2. It tells me to go down 2, right 1, down 2, right 1, down 2, right 1. Okay, or go the opposite way, up 2, left 2, left 1. Okay, and you can keep doing this until you feel like there's enough points on the line. Okay, my second equation I'm going to do in blue. Y equals 0.5x plus 6. Well, I don't like 0.5. I want to change that to a fraction. So this is the same thing as y equals 1/2 x plus 6. And remember, fractions are much better to graph with when we're doing slope-intercept one. Okay, so my y-intercept is 6. 1, 2, 3, 4, 5, 6. Okay, my slope is 1/2. It tells me to go up 1, right 2. Up 1, right 2. Okay, notice that's not getting me anywhere close to the red line, so let's continue the other direction. So I'm going to go down 1, left 2. Down 1, left 2. Down 1, left 2. Okay, and finally, connect the dots. Okay, notice they have a point of intersection right here. This is the point, negative 1, 2, 3, 4. 1, 2, 3, 4. So our point of intersection is negative 4, 4. Okay, which tells me that my solution is negative 4, 4. Okay, your turn. Please pause the video and try so obviously number 1, the letter A. Okay, so I'll do my first line here in red. So negative 2. Okay, slope of 1/2, up 1 over 2, up 1 over 2. Keep going. Okay, I could go down 1, left 2, down 1, left 2. Okay, there's my line. Okay, other line I'm going to do in blue, minus 7. 1, 2, 3, 4, 5, 6, 7. And I have a slope of 3, so up 3 over 1. Up 3 over 1. Up 3 over 1. Okay, connect my dots. Obviously, I'm not very good at connecting the dots, but that's okay. Here's my solution, is the point 2, negative 1. Okay, so please pause the video, try letter B. Okay, letter B, I'll do this one in red. 2x plus 10. Okay, here's 10. Uh-oh, I can't go up 2 over 1, so I'm going to go down 2, left 1. Okay, down 2, left 1. Down 2, left 1. Okay, connect my dots. Okay, the other one I'm going to do in blue. Negative 1/4 x plus 1, so here's plus 1. Negative 1 over 4. Okay, notice, again, I'm not getting close to my red line, so I need to go the other direction. So I'm going to go up 1, left 4. Up 1, left 4. Connect the dots. Okay, right here is my solution. That is point negative 1, 2, 3, 1, 2, 3, 4, negative 4, 2. Okay, there's those two problems. Okay, let's look at another one. So what is the solution to this system? Okay, so notice we have 15x plus 5y equals 25. Oh no, that's not in slope-intercept form. Okay, so we need to change that to slope-intercept form. Get it out of standard form and make it y equals mx plus b. Okay, so I'm going to just write down here so I have enough room. 15x plus 5y equals 25. Well, the first thing we need to do is get y by itself. So let's subtract 15x. Okay, 5y equals, remember we can't combine these, they're not like terms. I always write the x first because it's mx plus b, so negative 15x plus 25. Okay, it's still not quite by itself, so we need to divide by 5. Remember, everything gets divided. So this turns into the equation y equals negative 3x plus 5. Okay, so we can go ahead and graph. Okay, so plus 5, 1, 2, 3, 4, 5. Negative 3 tells me to go down 3, right 1. Down 3, right 1. Down 3, right 1. Okay, or you can go up 3, left 1. Okay, here's my graph. Okay, let's look at our second problem. Okay, I don't like this one either. I like it mx plus b. They have the b term first. Okay, so let's just rewrite it. So negative 3x plus 5. Okay, so if I graph that, oh, wait a minute. What do we notice here? These two lines are exactly the same. Okay, so when we have two lines that are exactly the same, it means every single point on either of those lines work. So this system has infinitely many solutions. Okay, because remember, lines go on and on forever, so they have an infinite number of points. So when they are the exact same line, we have infinite solutions. Okay, our next example, we want to solve these ones. Okay, so let's concentrate here on the first line. Okay, oh, again, it's not in slope-intercept form, so let's do some manipulating. Okay, so obviously we need to add 2x to both sides. So this just gives me y equals 2x plus 6. Okay, so I'm going to go ahead and graph. 1, 2, 3, 4, 5, 6. Okay, the 2 tells me go up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1. Okay, connect my dots. Okay, my second line, again, that's not in slope-intercept form, so let's do some manipulating. So we add 4x. 2y equals 4x plus 8. Okay, I need to divide by 2. Y equals 2x plus 4. Okay, so let's graph this one. 1, 2, 3, 4. I go up 2 over 1, up 2 over 1, or down 2 left 1, down 2 left 1, down 2 left 1. Okay, connect my dots. Okay, what do we notice about these lines? Well, first thing I'm hoping you're noticing is the slopes are exactly the same. So that means they're parallel. Okay, do parallel lines ever cross? Absolutely not. So this means there is no solution. Okay, no solution. Okay, your turn. Pause the video, try letter A, please. Okay, so 1/2 x plus 7. 1, 2, 3, 4, 5, 6, 7. Up 1 over 2, up 1 over 2, or down 1, left 2. Okay, connect the dots. Okay, this one I'm going to do in blue. Got to get y by itself, so we subtract 4x. So negative 8y equals negative 4x plus 12. Okay, we need to divide by negative 8. Okay, so we get the equation y equals 4 divided by a negative 4 divided by negative 8 is the same thing as 1/2. 12 divided by negative 8 is negative 1.5. Okay, so negative 1.5, negative 1, and a little bit. And I go up 1 over 2, up 1 over 2, up 1 over 2, or down 1, left 2. Okay, connect the dots. Okay, what do we notice? Well, slopes are exactly the same, so it means they're parallel, so there's no solution. Okay, please pause the video and try letter B. do my first line in red. We don't like that, so subtract 3x. Okay, so we get 2y equals negative 3x plus 9. Divide everything by 2. We get y equals negative 3 halves x plus 4.5. Okay, so if I start graphing 4.5, 1, 2, 3, 4.5, and I go down 3, 1, 2, 3 over 2, down 1, 2, 3 over 2, okay, or I can go up 3 over 2, 1, 2, 3 over 2. Okay, connect my dots. Okay, if I focus on my other line, okay, I need to divide by 2/3, or the same thing as multiplying by 3 halves. Okay, so be careful over here, you do it to the whole side. This gives me y equals, I'm going to flip, so I get, let's see, 9 over 2 minus 3 halves x, okay, or y equals negative 3 halves x plus 4.5. Oh, they're the exact same line. What does that mean? Infinite solutions. Okay, so now let's look at a word problem. Monisha and Holly have 14 more days to finish reading the same novel for class. Monisha plans to read 9 pages each day, while Holly plans to read 20 pages each day. Assuming Holly and Monisha both maintain their reading plan, when will Holly catch up with Monisha? Who will finish reading the novel first? Okay, so the thing with this one, sounds like we're in slope-intercept form. Okay, remember, if I read do something each day or per, that's my slope. Okay, so Monisha, we know she reads 9 pages each day. So that's 9x. Where does Monisha start? Well, if I look at her library, she starts on page 96. So 9x plus 96. Okay, now we look at Holly, 20 pages each day. So y equals 20x. Where does she start? Page 6. Okay, now I don't know about you guys, but I don't want to graph something that starts at 96 and another equation that starts at 6. That's a pain in the butt to do by hand. So with problems like this, it is very nice to use Desmos. Okay, so if I open up my internet and I go to desmos.com, I'm just going to type those straight in. So I equals 9x plus 96, and y equals 20x plus 6. Okay, I want to see where these intersect, so I'm just going to drag till I find them, and it's going to be high up, because remember, this y-intercept at 96 is quite big. Oh, starting to see the red line now. Okay, keep dragging. Of course, you could use the wrench and change the domain and range if you wanted to, but sometimes it's easier to do this when you don't know exactly where you're going to be looking. All right, so they're intersect somewhere in here. So the cool thing about Desmos, if I click, oh, it gives me the point. Okay, so this point is 8.182. Okay, so I get the point 8.182, comma, 169.6. 169.6. Okay, well, we know X was the number of days. So in just over 8 days, they're at the same place. Okay, and that is just over 169 pages read. Okay, so when will Holly catch up? She'll catch up at just over 8 days. Now to finish who will read the novel first, well, I know I've got to get to 220 pages. So if I go back to Desmos, I'm looking at my y-axis, because y is the number of pages. Who gets to 220 first? Well, 220 is here. Who hits it first? The blue line does. Okay, and who was blue? Well, the 20x plus 6 was blue. So that was Holly. So Holly will finish reading first. Okay, that's how you do that word problem. Okay, so here's a problem for you to try. So suppose Manisha reads 10 pages each day instead. Okay, so her slope instead of being 9 is going to be 10. Okay, how will that change the length of time it takes for her to catch up? And will Holly still finish the novel first? Okay, pause the video and try this problem, please. Okay, so I'm going to come in and I'm going to go straight back to Desmos and change that 9 to a 10. And let's see what happens. Okay, change the 9 to a 10. Okay, so let's see, when do they meet up? Okay, let's keep scrolling. Keep dragging down. Okay, somewhere in here. Oh, there it is. Okay, so if she reads 10 pages a day, she's going to finish the book in 9 days. Okay, and they'll meet in 9 days, and they'll both be on page 186. Okay, to determine who finishes the book first, again, we're going up to 220. Okay, it's that blue line, which is that 20x plus 6. Okay, that 20x plus 6 was still Holly. Okay, so Holly still finishes the book first. Okay, so the last thing we're going to look at is solving a system of equations approximately. Okay, approximately means give your best guess. Okay, so this book suggests using a graphing utility. Let's just do it by hand. Okay, so if I throw a graph in here, okay, very easily do this by hand. Okay, my first equation, y equals 2x minus 3. Do that one in red, so minus 3, 2x, 1, 2 over 1, up 2 over 1. Or I can go down to left one, okay, and connect my dots. Not a very good line that time, oh well. Okay, this one I'll do in blue, so plus 6, 1, 2, 3, 4, 5, 6. And I'm going to use my slope as a negative 5. 1, 2, 3, 4, 5 over 1. Down 5, 1, 2, 1, 2, 3, 4, 5 over 1. Okay, so they cross right here. Okay, we really don't know what that is. It doesn't cross nice and pretty. So it looks like we're 1 and a little bit, so maybe a quarter, so maybe 1.25. And we're going down just a little bit, maybe 0.25. Okay, so that would be an approximate situation. Okay, they suggest using using Desmos, which you could if you wanted to, and so they give you the answer here. Okay, they say it's correct to 3 decimal places, but it's not an exact solution. So they want us to come up with the exact solution. So what we can do instead of finding it approximately and kind of just giving our best guess is we can set the expressions for y equal to each other and then solve. Okay, so since these are both y equals, I can say, oh, this is equal to y, so I'm going to replace this y with this stuff. So negative 5x plus 6 is equal to 2x minus 3. Okay, I'm just plugging that in. Now we can solve using algebra. Okay, we can add 5x to both sides. 6 equals 7x minus 3. Add 3 to both sides. 9 is equal to 7x. Divide by 7. X equals 9 over 7. That is an exact solution. Okay, to get y, I just take this value and plug it into x. Okay, so y equals 2, but instead of writing x, I'm writing 9 over 7 minus 3. This gives me y equals 18 over 7 minus 3. So this is, let's see, this would turn into 21 over 7. So 18 minus 21 is negative 3. And if you throw those in a calculator, those will be equivalent to what we found. Okay, big thing here, just graph it by hand and find where they cross, okay, and give me your best guess. That's what it means to approximate. Okay, so I'm not worrying about this example because we're going to talk more about finding an exact solution with our other methods we're going to learn in this chapter. Okay, so that's how you graph solve systems of equations. Graph them, find where they cross. Okay, most of the time this is what we're dealing with, just one place. Sometimes you get the exact same line, so it makes infinitely many solutions. And then sometimes we get parallel lines, which means no solution. So homework tonight, you are on page 148. You're doing problems 9 through 11, 13 through 25 odd. I would suggest having some graph paper handy. Hope this makes sense. See you guys later.